Hey y'all, I'm Sam and I'm a chemistry and science tutor here on Wyzant. Today we're supposed to assign oxidation states to bromine in the following compounds. So these can get a little tricky, but we have resources like the list that I have on the right here that kind of tell me what rules I need to follow in order to determine what the oxidation state of each of the elements in the compound will be. So first we have HBr. I can start going down my list and see which rules apply. I don't have any elemental forms here, don't have atomic ions, not group 1A or 2A. Finally, we get to hydrogen. Hydrogen has an oxidation state of +1 when bonded to a nonmetal. Br is a nonmetal, so H is going to be +1. That's all we have so far. Another helpful rule, well, not oxygen and not fluorine clearly, is that my neutral compound means that all of the oxidation numbers will be 0 when I add them all together. So that means that the H and the Br together have to give me 0, which must mean that Br must have been a -1 oxidation state. Great. See if we can use the same logic for question 2. HOBr. Again, we find ourselves at hydrogen, which has a +1. Again. Then our next rule says oxygen has a -2 because this is not a peroxide. And then our last rule says, what must bromine have been to create a neutral compound? +1 minus 2 is -1, so Br must have been +1. Kind of strange, because -1 seems a little bit nicer. We're used to seeing bromine in group 17 on the periodic table, which means that it gains an electron to have a charge of -1 to look more like a noble gas. But remember, charge and oxidation state are not synonymous, so we're going to have different answers based on the context of the problem. Alrighty, bromine is actually an element. Br2 is the elemental form of bromine because bromine is diatomic in nature, which means it just bonds with itself, kind of like twins that are inseparable. And it means that the overall oxidation state for each bromine is 0. Sounds pretty easy. Lastly, we've got Brf3. I go down my rules until I hit the relevant one, which I think is fluorine. Fluorine is always -1 for each one. So we've got 3 -1s, and that needs to come together with something for bromine to give me a sum of oxidation states that equals 0. So you could always use the real algebra if you need to move this to the other side, but for me, I can just see that bromine must have been +3. Okay, I hope that was helpful. Thank you so much.